This chapter belongs to chemistry, and the good thing about, or good thing, or whatever we say, the importance of this chapter is, in 8th you are understanding the fundamentals of this chapter. A lot of this content will be repeated in grade 10. 8th there is no resemblance in 9. 9's resemblance is again in 11. So 8th resemblance will come in 10th, okay, unless and until they change the syllabus. Yeah, so there we will study a chapter called acid, bases and salt, in which, no, you studied it, but you have studied it. I'm saying in grade 10, when we study acid, bases and salt, a lot of knowledge will be derived from this chapter, right? So this chapter becomes important. And when we come to grade 11, we'll be studying something called electrochemistry. And electrochemistry, very basic part you're going to study now. This is very interesting. So you will learn about few terms and concepts which you will carry on from now on, right? Like say you learned about something called integers, rational numbers. You'll be carrying it throughout now till the time you study. Okay, so chalte hain. And chapter's name is chemical effect of current. So let's write the name of the chapter and then slowly we will take this chapter up. Chemical effects of electric current. Very strange name. Generally chapter names are always like force and pressure, combustion. This is like chemical effects of electric current, as if we are studying a very small, some effect ko leke ek chapter bana diya. So that means there must be some sort of importance to it. Okay, so we start our discussion with, in order to understand chemical effects, let's just take a broad perspective on electric current. Now when I talk about electric current, this is not a chemistry topic, it's a physics topic, right? So if you pick electric current, then electric current has 3 effects. And this is what again you will study in grade 10. Upfront I'm saying electric current has 3 effects and you will study this in grade 10. Something fell over. Oh, it's also true lines. Okay. Right. Chalo. There's no mesh door out here. If you close that, it will be. So there are 3 effects of electric current. 1, 2, 3. The first effect is known as heating effect. Heating effect. Every day you bathe with hot water, you use the geyser, you're using electricity to create heat. You're toasting breads, you're using electricity to create heat. You're baking a cake, you're using electricity to create heat. So that is known as heating effect. Chhod do usko, chala jayega. Okay? Then the next one is known as magnetic effect. And this will eat your head a lot in grade 10 as well as grade 12. Magnetic effect. Through electricity, you can also create magnetism. Okay? Electromagnet, like the way we are having our calling bell and other things. Now, these are the first and the second effect. Now, these 2 effects are actually studied under physics. This is also studied under physics. And the third is known as chemical effect. And this will be studied under chemistry. So let's first understand what we are going to study. We are going to study 1 out of the 3 effects of electric current, and that effect is typically attributed in chemistry called chemical effect. Okay, now let's understand something more. Let's say we look at our home and we look at the wires that carry electricity, wires that carry electric current. Okay, wires that carry electric current. Let's look at our home. Try and understand. There's another copy. Okay, let's say we stepped into our home. Let's say I'm giving my example. We stepped sometime at 2012 out here in the home that I'm staying. And what is the year today? 2025. So how much time has elapsed? Around 13 years have elapsed. Now tell me, was electricity coming into my house in 2012? Yes. Is electricity still coming into my house? Yes. And they're coming through these wires, right? And if you look at these wires are solids. Typically, they would be made out of copper, right? So if I'm enjoying the same, what you call the intensity of electric current without any distortion or anything, one thing is for sure, that this solid over the period of 13 years has not changed. Means the copper has remained copper only, right? So I would say that no chemical change took place. Do you agree or not? The wire must have got heated for some time, but no chemical change. This copper is still a copper wire over the last 13 years, right? And this is a solid. So if I now try to do one more thing, let's say I take a liquid and let this liquid be an acid, okay? An acid, a dilute acid. And through this dilute acid, let me pass electric current. Now there will be a change. If you pass electric current through a liquid which conducts electricity, okay, like an acid conducts electricity, we'll get into it. I'm just giving a brief idea. If you pass electricity through an acid, for some time, this acid will no more remain as an acid. There will be a chemical change. Acha. Do you guys know what is the difference between chemical change and physical change? Okay, in chemical change, always remember what is chemical change. The thing is new substance. Always remember this, new substance with new properties. Okay, new substance with new properties are formed. Remember that. Now I'll give you more interesting examples. And these properties would be entirely different from the parents who actually gave birth to that kid. Let's see one fine example. Hydrogen is a gas which is highly explosive, bhasmasur. Oxygen is a gas which supports combustion. Their child is water which extinguishes fire. Entirely different, like Bhakta Prahlad, born in the kingdom of demons, but he is a worshipper of Vishnu. Got it? So their properties will be entirely different. And one more example I can give you. You take some iron, you take sulfur. Sulfur is a yellowish powder. And you take iron finely powdered, and you mix iron and sulfur. Just like that, like a bhel puri. Bring a magnet and just again turn it, all the iron will be sucked out by the magnet. That is not a chemical change. But if you take that bhel puri mixture of what? Sulfur and iron, and you heat it on a pan, it will completely turn black. Now if you bring on a magnet, no attraction is seen. That means the new substances with new properties will be formed. I have a piece of paper, I have torn it into 1,000 pieces. It's a physical change. Water melting into ice, and then ice melting into water and further evaporating into a water vapor is also a physical change. However, if you have milk which has turned into curd, that is a chemical change. A chemical change usually cannot be reversed. Just remember, if you want to write down, I'm just saying, a chemical change cannot be reversed by usual methods of like heating or cooling. Yes, we can reverse it, but that's not so easy. And whenever a chemical change happens, energy transaction will take place. Either energy will be absorbed or energy will be released. These we will learn in many higher classes. For example, let's say I bought a lot of coal in my house and I've kept it. Now this coal, there is oxygen present in the atmosphere. Do you expect carbon dioxide to happen? No, carbon dioxide will not happen. You have to supply energy. That means coal will first absorb energy, then it will burn, and then it will give out much more amount of energy in the form of heat. And then when you get carbon dioxide, that is completely different from either carbon or oxygen. So that had no relation with this chapter. But what I wanted to tell you is that when electric current flows through solids, typically conductors, they do not create any sort of change in them. And the live example is my house, your house. But if electric current is passed through liquids which conduct electricity, then they will create a chemical change in them. That's why this chapter is called Chemical Effects of Electric Current. So one thing that becomes more clear from here is that from now on, whatever I study, I will be dealing only liquids. I cannot deal solids, because in solids no chemical change happens. Name of the chapter is Chemical Effects of Electric Current. So I will be dealing only liquids. And those liquids who conduct electricity, because if the liquid doesn't conduct electricity, then there is no point in talking further about it. So this is just a preliminary introduction that I wanted to give you, that when you talk about electric current, it has got three effects: heating, magnetic, and chemical effect. These two are studied in physics. This is studied in chemistry. Why do we study in chemistry? Now you know, because there's a chemical change. There's a lot of chemistry that is involved out here. This is not something in which you will find so much of heat or so much of magnetization has been produced. No, we expect a lot of chemical changes to happen in this case, right? Further, to understand our concept, I said that when electric current flows through solids, then they do not create any chemical change. Our copper over the last 12 years are still copper wires. But if we pass electric current through any of the liquid that conducts, then there will be a change observed, and that change is known as chemical effect. That change is caused due to chemical effect. This is just the basics that was given. Can I move to the next slide? Okay, so let's now understand. So further, when we are going to talk about this chapter, today we'll talk about liquids. Okay, so if you have a liquid, then there is again two options: can conduct electricity. Okay, what do you mean by can conduct electricity? Can conduct electricity means electric current can flow through this liquid. Okay, another can be cannot conduct electricity. So since our chapter is all about chemical effects of electric current, these kids are not of our interest, because we want these kids who conduct electricity. So if you conduct electricity, a liquid that conducts electricity is known as electrolyte. Very good. A liquid that conducts electricity is known as electrolyte. And before that, just for your understanding, I can also have a solid. A solid may conduct and may not conduct what? Electricity, electric current, okay, or electricity. So I'm saying may conduct electric current. This part is not needed, but in your understanding, in your chapter, but your understanding wise, it will become correct. A solid may conduct electric current. If it conducts electric current, I call it a conductor. I call it a conductor. And if it does not conduct, what do I call it? Anyone? Insulator. That's it. That's how you study. This is called an insulator. So ये जो concepts है ना, kiddos, these concepts should be very clear with you. Never ever use the word conductor for something like acid. Acid will be an electrolyte because it belongs to the family of liquids. Got it? Conductor means it's a solid. And a solid who does not conduct will be called as a insulator, right? So if you conduct electricity, you will be called an electrolyte. If you don't conduct, you will be called a non-electrolyte. Children who go to school are also referred as students. And in those students, we can have good students, average students, excellent students, right? So our interest is now in this chapter only on this part, right? So if you are electrolyte, then further it goes, do all liquids conduct electricity at the same extent? Well, no, not at all. So let's go for the example out here. When you have conductors, they can be further classified as, good conductors and bad conductor. Children, understand, a bad conductor is not an insulator. A bad conductor is somebody who will conduct, but not to the extent that this fellow will conduct. So if you want some example, the best conductor of electricity in solids is silver, Ag, argentum, okay? Silver, then we have got copper, then we have got aluminum, all these, zinc, all iron, everything, but they are the best conductors. That's why when you see the motherboard of a laptop or anything, the entire soldering is made up of silver soldered, because silver is an excellent conductor. We could have used silver wires also, but a lot of pilferage will take place. That's why copper wires are used. Aluminum is also a good conductor, but aluminum is very brittle. Aluminum wires are not used because if you use aluminum wires, then you have to again give a guide wire also, which is of iron. Cost goes up. Aluminum cables are therefore called, these are for your interest. Whenever you see aluminum cables, they are called armored cables, ARMOD. The reason is, if you take aluminum cable from say D tower to C tower, the cable will hang in between and break. So what you have to give? You have to give another guide cable along with it, which is actually an iron cable. So the cost goes up. Have you seen network cables when they are opened up, sometimes slit? There will be a plastic sheath in between through which the wires are going. If the wires were going alone, they're too brittle to break down. That's why the network cable looks very heavy. Heavy is not due to the wire. Inside the network cable yellow sleeve, there will be one plastic sheath. And in that sheath, the wires are running. Okay? So you can be a good conductor, you can be a bad conductor. Like if you compare iron is compared to silver, then I would rate iron as a bad conductor. That does not mean Sir said bad conductor, so I'll not get shock. You will get a shock. But here you will get super shock. There you will get a little bit less. Okay. And insulators, well, very easy. You can have mica, then wood, plastic. Okay. These are called insulators. Now, I won't discuss anything more on this right-hand side because our chapter is on the left-hand side. Okay. So let's talk about electrolytes out here. The first thing, and this is your first term for which a definition might be asked to you. What are electrolytes? Electrolytes are liquids that conduct electricity. Electrolytes are liquids that conduct electricity or that allow electric current to pass through them. Electrolyte is a liquid. Always remember, electrolyte is a liquid and it helps to conduct electricity. Clear? If I ask you what is a conductor is a solid that allows electricity to pass through it or that carries electric current through it. Now, in both these cases, we will use a word carry. Carry. Carry gives rise to another word called carrier. Carrier, like a courier service. Who is carrying this electricity, right? If we talk about in solids, then, okay, and to understand that, let's go a little bit one step back. So let's talk about electric current. Okay, what is electric current? It is the flow of charges. It is the flow of charges. And this flow of charges can happen only when there is a charge carrier. So what we need is something called a charge carrier. जब तक charge carrier नहीं है, a substance cannot conduct, whether you are solid, whether you are liquid. A liquid conducts electricity. What is electricity? Flow of electric charges. Flow of electric charges. Through in grade 10, you will learn through any cross section over a time. Means you sit like a fisherman, charges are flowing. Charge should keep on flowing. Don't you hear this thing? Parents keep on telling us when we go for picnic, hey, don't go to the river, it has got a current. Current means flow of a stream. Flow of anything is called a current. Wind current, right? Air current. This is electric current. So in water current, what is flowing? The stream is flowing. In wind current, breeze is flowing. So in electric current, what is flowing? Charges are flowing. But the charge to flow, there has to be a charge carrier. We said there is a lot of goods movement in terms of e-commerce sites like Flipkart and Amazon, Myntra and all. Who is carrying those? DHL, FedEx, Blue Dart, all logistics, Safe Express, Express Bees, whatever you say. So you need a charge carrier, right? So if you look at a solid, there also we should need something called a charge carrier. Now this is your next important concept that you'll understand. In solids, the charge carrier's name is electron. Okay, electron. So electrons are the charge carrier in the case of solids, which conduct. So in better ways, I should say, who carries the charge in a conductor? Electrons carry the charge, right? Your next question should be, that means, sir, in insulator, there are no electrons? Cannot be. Everything is matter. Matter is composed of atom. Atom should have an electron, a proton, and a neutron. So, yahan pe, so we will now add an adjective. Like Sarvesh is a boy. What boy? Naughty boy. So the word is, this is more advanced, free electrons. And we'll talk about that. You should have free electrons. Free electrons can only carry charges. In this case, the electrons are not free. In this case, what do we call? The electrons are bound electrons, not at your level, but if you want to understand, इस case में electrons are not free. Here the electrons are free, and we will understand also what are free electrons. Okay, after a little bit of time. So free electrons help electricity to be conducted by solids, and they are the charge carriers. And so in solids, how many type of charge carriers you have? One type, and that one type is known as free electrons. But when you come to liquid and you talk about its charge carriers, the charge carriers are not electrons. The charge carriers are known as ions. Okay. So we will go to our next slide and we will again summarize this. We have to understand this chapter very dhire dhire. Okay. So what all did we understand so far? Do you understand what is the three effects of electric current? Heating, magnetic and chemical. Heating and magnetic are kept in physics, chemical is kept in chemistry. Why? Because when electricity flows through a liquid that conducts electricity, sir, use a better word. Okay, when electricity flows through an electrolyte, it creates a chemical change in it. What is a chemical change? In very short, some chemical reaction will take place. So chemical reaction cannot be studied under physics, it has to be studied under chemistry. Then, sir, what is this difference with solids? Well, solids, when electricity flows, it doesn't create any chemical reaction. The wires of our house are the same over the last 12-14 years. Understood? So a solid which conducts electricity is known as a conductor. A liquid which conducts electricity is known as an electrolyte. In a solid, the charge, and then we should understand what is electricity or electric current, flow of charges. And when the charges flow, they should have a charge carrier. And these charge carriers, in the case of solids, are electrons, free electrons. Because if you say electrons, then you should ask, what great mistake did insulators do? Don't they have electrons? They also have electrons. Their electrons are bonded. Their electrons are like their mother say, hey, sit! No roaming around. Yeah, and their electrons are like Pebble City kids. Anytime playing outside. Anytime playing outside. Understood? But in the case of electrolytes, the charge carriers are ions. Let's move to the next slide now, okay? And do a little bit of, again, revision, okay? Now, there is nothing called free ions, I'll tell you that. Conductors and electrolytes. Electrolytes. Now differences नहीं, अब तक हमने जो पढ़ा ये कोई आपको नहीं बोलेगा. Nobody will ask you this difference because your chapter is all about that. This I am doing for your concept purpose. Conductor means number one has to be a solid. Do you agree? Electrolyte means it will be a liquid. Second, no chemical change. Are they so lucky that they should not undergo any change? They do undergo change. Heating, magnetic. When you pass electricity through a wire, doesn't the wire get heated? Yes. Don't we make electromagnet out there? That's you should remember. There's no chemical change, but they're blessed with two different type of changes. That is heating effect as well. And both are physical changes. Okay. But in this case, we will say there will be a chemical change. And chemical change means, in short, there will be a chemical reaction. Therefore, there is a chemical effect. Clear? So far? Further we say that free electrons are the charge carriers. And if you look at, then we'll say ions are charge carriers. Okay, that means now our discussion should be, again, in the book we need to go on this side, but we all love science, so we'll understand a little bit ये free electrons क्या होते हैं और ये ions क्या होते हैं, then only we'll get. ठीक है? Any doubts so far? Yes. Okay. Yeah. Any issue? Anyone has any doubt? Okay. चलो अब थोड़ा देखते हैं ions क्या होते हैं. This is just for your interest, huh? What are free electrons? So let's say we have a piece of a conductor. Okay. This is a solid conductor. And this conductor is connected to some electricity source, which can be either a cell or a battery. Electricity source. Not at your level, but again, you should know what happens. This conductor must be made up of some metal, right? This has to be a solid, and the solid further has to be a metal. That means the metal will have a metal atom, and then the atom will have electrons. And in these electrons, there will be two categories. Some electrons will be bound electrons or bonded electrons, and some will be free electrons. And these free electrons, just for your understanding purpose, if you understand English, Hindi, they are like awara electrons. They बेकार घूमते रहते हैं. Okay? Now, there must be thousands of atoms for this much small portion. Every atom will have some free electrons. And these free electrons means atom 1, atom 2, atom 6001, atom 18,46,346. Everyone is donating free electrons. These free electrons slowly become what is known as delocalized. Okay, let us understand what is delocalized. Delocalized means they lose their parental information. Let me give you an example. Parental information. If you suddenly ask, hey, you are attached to which atom? पता नहीं कल से यहाँ घूम रहा हूँ मेरे को मेरा घर नहीं पता इनके साथ घूम रहा हूँ. So let's say what is a delocalized asset? Have you seen a wheelchair in every tower of ours? Yes. Are you allowed to use it? Yes. 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 Who paid for it? You and me paid for it. Are you allowed to keep it in your home? No. Delocalized asset. We all paid to buy that wheelchair, but it is a common asset. You can use when you need it, but you can't store it in your house. This electron belongs to some atom, but now has lost its identity. And like him, there are millions of such free electrons. That's why I use the word avara. ऐसे ही घूम रहा है, vagabond. They don't know anything about themselves. And when they become delocalized, we call them as sea of electrons. Sea of electrons, or we call them as cloud of electrons. And these electrons are something like this. ऐसे random direction में घूमते रहते. Random direction.
Like how gases.
Like how gases are. Hey, where are you going? I'm going to Ratnadeep. Where are you? Pinks and blues. Like that. Suppose there is an electricity source and you apply some voltage across this. Let's say this be the plus side and this be the negative side. I have applied some voltage. So this becomes the plus side and this becomes the negative side, right? Now, like charges repel. We know that this is negative. All the electrons will, they start getting a repulsion. Once this electric current is sent, then immediately these avara electrons become the most well-behaved electrons. And they will all become aligned in one direction. Have you understood? We call them that they have got aligned. And their flow keeps on happening. Electrons are never born or never do they die. The voltage source acts as a pump. The electrons will come this side. Now they have to go to this side. Why will electron love to go to negative? It's already negative. So you have to kick it. Therefore, in higher classes, you'll study the battery supplies something called an EMF, electromotive force. So it will go here, again repel and keep on. Once, and how is the battery supplying electromotive force? See, we are deviating, but we are learning new things. Inside the battery, chemical reactions are happening. And those chemical reactions are giving rise to electricity. The day the chemical reaction happens, no more electron flows. They again become avara and your clock stops. So you have to replace the cell again. And so battery does not give birth to electrons. It is the same electrons which have to keep on circulating. Have you understood? So this is the concept of free electrons. Free electrons are contributed by each atom of a metal. However, the electrons lose their localization identity. Where did you come from? पता नहीं साहब, 20 दिन से इधर ही घूम रहा हूँ और मेरे साथ और भी हैं. There are many like me. Okay, they're roaming all around. Then comes the next concept that how many like you? So a sea of us. Any good thing that you all can do? Yes, give us any external potential, we become aligned. We become very good boys. In the case of insulators, these free electrons are not there. And if these free electrons are not there, then they will not conduct. So when you go to higher classes, you will study same element carbon. When it comes in the form of diamond, it does not conduct electricity. But because in diamond structure is such that you don't get free electrons. But when it comes in this form of graphite, which is there in your pencil lid, at that time it has got free electrons. Graphite is a very good conductor of electricity, whereas diamond does not conduct electricity. Both are from the same element, carbon. Have you understood? So this was not a part of your chapter, but I said so that you understand what is the concept of free electrons. So in solids, and in grade 10 you will learn this again. In solids, electricity is conducted by free electrons. If a solid does not have free electron, what will I call it? Insulator. And a bad conductor will have less free electrons. A good conductor will have more free electrons. Concept clear हुआ अभी? ठीक है? हाँ. Rechargeable cells. Rechargeable cells have a different type of reaction. Reaction gives rise to electricity. That's a reversible. Then again we will give electricity. It will reverse the chemical reaction. Store back them. Aram se. Have we understood the concept of free electrons? Okay. Now let's understand the concept of ions. This you will need in grade 9. Ions. Okay. What is an ion? An ion is something like an Atma. Ions don't exist at all. It is like, we call it intermediate entity. It is an intermediate, बीच का है entity. If you tell me go and bring some ions, it cannot be brought. But during a stage, they will be formed. Formation होता है. It's an intermediate. So what is an ion? So let's talk about an atom. Does an atom contain charged particles? Yes. The charged particles inside an atom are electrons and protons. Okay, these are the charged particles. A proton is a positively charged particle, an electron is a negatively charged particle. Now let's say our atom, we try to make it neutral. Neutral. If you try to make it neutral, that means N stands for count. The count of electron should be equal to the count of proton. Then only each protons, then only they'll balance. If there is any disturbance in this, then the atom is no more neutral, it becomes charged. Ion is actually a charged atom. Now, how does that happen? Well, if I look at an atom, just for your understanding, an atom has something which is called a nucleus, which you will learn in grade 9. It's a central core. In the nucleus, I have neutron and I have protons. Neutrons are very interesting. They are neutral particles, so they will not disturb you. And on them orbiting are electrons are orbiting, right? Now see, if an atom has to become charged, that means this equation cannot be met. Either positive charge should be more or negative charge should be more. Now, as a layman, you will say, sir, more negative charge, I know, it has to gain an electron. More positive charge means it has to gain a proton, but no, it's not like that. Proton is something, proton ka position kahan pe hai? It is in the nucleus. Proton is absolutely sitting in front of the mother. Can I go out? Cannot. Everything that can happen is with electrons. So it is always, remember, it is the electron that can either be lost or gained. You might gain an electron from someone, or you might lose an electron. Okay. So let's see the arithmetic now, how it happens. Suppose I am an atom, and I am an atom in which my electron count is equal to my proton count. That means I am what? I am neutral. I am neutral. Okay. Now say suppose I am an atom and I gain one electron, then whatever atom I was, I will be blessed with one additional negative charge. Did you understand this logic? Say I had 20 electrons, 20 protons, net zero. Now I have got 21 electrons and 20 protons. 21 and 20. If you do the arithmetic, it is -1. That is what is coming out here. Okay? Another way can be that I am an atom and I lose an electron. Now I become one positive. In this case, I am an electron, so I have become -19 and +20, so I'm +1. Did you understand this logic? Right? So what is an ion? An ion is an intermediate entity. Then its second point would be it is a charged entity that is formed after an atom has either gained or lost an electron. Either you have gained an electron or you have lost an electron. तो भाई साहब एक और चीज आता है. If you gain an electron, you are an ion who is negative. If you lose an electron, you are an ion who is positive. मतलब ion दो प्रकार के होते हैं. Ions are of two types. Is this getting clear or not? Negative and positive. So further we should say, what are ions? Ions are intermediate entity. Those are charged entities. So this is our first point, this is our second point, and this is our third point. So once an atom loses an electron or gains an electron, it becomes a charged entity, and I cannot call it atom anymore, I call it an ion. ठीक है? आगे चले? थोड़ा सा और आगे. So further I say an ion can be a positive ion and an ion can be negative ion. If you are a positive ion, you are called a cation. If you are a negative ion, you are called an anion. Now many children will confuse this. Now look here, the beauty part. Look here. Many children will confuse this afterward. Anion was positive. So whenever you write cation, you should write cation. Do you understand the logic? Cation. So cation is always positive. That means anion has to be. Did you understand this trick? The way I wrote the T looks like a plus. So cation is always positive. देखो आप कितना कुछ सीखे हो, एक्स्ट्रा सीखे हो, पर आपके काम की चीज है.
NaCl is also considered as an ion, right?
No, I'll tell you. Don't worry. So NaCl is a molecule or a formula unit, to be better known as. So what are ions? Ions are intermediate entity that are charged, which are formed after an atom either loses an electron or gains an electron. So if you lose an electron, you gain a positive charge and you are called a cation. If you gain an electron, you gain a negative charge and you're called an anion. So we'll go back to my slide out here again in this slide. So if you see that the free electrons are charge carriers and here ions are charge carriers. Here the discussion stops right here, but free electrons are of one type only. But when you talk about ions, then we have got cations, and anions. Now the discussion is very nice. Electrolytes are liquids that conduct electricity, and the charge carriers in electrolytes are of two types, cations and anions. That's why I always tell children that electrolyte has got DTDC as well as blue dart, whereas this one has got only DTDC. इसके पास blue dart नहीं है. ठीक है ना? Now, is this understood? And since she brought up the topic, so we have a element called sodium. Sodium is represented by Na because sodium's trivial name is natrium. Sodium is a metal, so sodium will lose one electron and gain a positive charge. This is called sodium ion. This is sodium atom. ये दोनों एक नहीं है, ये आयन है, ये एटम है. And this, see, as I told you, electrons are never created or destroyed. Suppose you must be hearing many people buy and sell shares. I sold so many shares in share market. You can sell a share only when there is a buyer for that share. Otherwise, your transaction will not be honored. And you can buy a share only if somebody is selling the share. So this fellow can donate this only when there is an acceptor for this. And when it donates it, right, and it becomes plus. And our chemistry teacher was a Malayali sir in Assam, and he used to say, yes, sodium electron देने के बाद कालंक ले लेता है, इधर इधर कालंक आ गया उसको. He got it. And this electron is roaming. Where do I go? उसको chlorine आता है. Chlorine says, come to me. I will take that negative charge. And this is known as a chloride. Chloride ion. This is a chlorine atom. Now look at this in the form of a linear equation. This one cancels this one. Finally, what do you have? Sodium plus and Cl minus. So this is your cation, agreed? And this is your anion. And what did you study? Unlike charges attract each other and they will bond each other. And this is what you eat every day, and table salt. And this bonding is so strong that if you take salt and you try to heat in a pan, you cannot melt it. It melt nahi hoga. And this bond in higher classes we'll study as electrovalent bond or ionic bond. तो आगे अगर वो सब चीज समझना है, ये basics clear होते जाने चाहिए. Have we understood? This was only because Mishka brought about a discussion. This is nothing to do with your chapter. All that we know is that in a conductor, free electrons will conduct electricity. In an electrolyte, ions will conduct electricity. And ions are of two types. What are the ions? Cations and anions. So electrolytes have two types of charge carriers, whereas conductors have only one type of charge carrier. He's superbly disinterested and disengaged. Charvik, do you know something called disengaged and actively disengaged? Do you know the difference between these two? A disengaged child will be disengaged. An actively disengaged child will disengage another active child. So when we say there is an actively disengaged child, we say it is always good to place him at home, or an actively disengaged employee. You have no work, right, in the office. So he's working. Hey, what are you doing? Hey, last Sunday now we went to that mall. You know what happened? This is called actively disengaged. The actively disengaged will disengage another one. So we used to say, ask him to be at home. He coming to office means two more people will not work. And I don't know what happened. You didn't sleep today? But what are we are so disengaged? Is this much understood? Right? So we now go back to our main discussion. And our discussion is all about electrolytes. So electrolyte. So what is an electrolyte? A liquid that conducts electricity is known as electrolyte. Now we come back to grade 8 and the examples of electrolyte. The examples of electrolyte are acids, bases, not salt. If you write salt, you will get a 0. Salt solution. If you take a bowl of common salt or table salt and you put two electricity probes on them and you ask somebody to touch that, he will get no shock as long as there is no moisture. But if you now start putting water on that salt, immediately the electricity will start conducting. Salts do not conduct electricity because you knew that for electricity to conduct, ion must be created, and ions are always created when the stature is aqueous. Aqueous means ions are always found in aqueous state, right? So let's say when we talk about acids, although you don't understand the formulas, let's say I take an acid which is, say, hydrochloric acid. Hydrochloric acid. If hydrochloric acid is concentrated, then it will never conduct electricity. It has to be dilute or in aqueous form. So we write it as HCl in aqueous form. AQ means water here. So this will give you a H plus ion, which is in aqueous medium, and a Cl minus ion. This is higher grade. That's why it conducts. Got it? NaCl will not conduct electricity unless and until it is in aqueous state. Pani dal do, salt solution, superb, it will conduct. So acids. Another for bases, an example of base is sodium hydroxide. If you want to know the formula, then sodium hydroxide is NaOH, aqueous. This will actually split up to sodium plus aqueous and hydroxide ions, which minus aqueous, conduct electricity. And salt solution, which we already know, sodium chloride solution. So we'll call this now as NaCl, again aqueous. So it will give you what? Na plus ions it will release, and Cl minus ions it will release. So electrolytes are liquids that conduct electricity, and the charge carriers are ions. So those are the ions. What are the ions in HCl? H plus, Cl minus. Who is the cation? Who is the anion? Cation, anion. Cation, anion. And you know, cation. Okay, so cation. Fine. Then further we say, as you studied in solids, you had good conductors and bad conductors. Similarly, here we will have strong electrolytes, and we will have weak electrolytes. In grade 10, we will study a little bit more deeper on what is a strong and a weak. But here what we understand, a strong electrolyte is one which allows electricity to handsomely pass through it. Means the value of electric current passing through a strong electrolyte will be very high, and the value of electric current passing through a weak electrolyte will be very less. So in grade 8, we try to understand how to know whether a given liquid is a electrolyte or non-electrolyte. First is this electrolyte, and then comes, if it is a non-electrolyte, you don't do the next test. If it is strong electrolyte, if it is electrolyte, then we'll do the next test. Okay, तो उतना देख ले, just how to know, or you want to stop here? Want to stop here? No issues. We have got enough time to study. We have just one chapter and one sound chapter left. But at least read till this much and come. Our next class, we will try to understand. At least watch the video. I'm uploading videos every night itself, so that when you come back from school, you get it. So how to know whether a given liquid is an electrolyte or not? So just one quick revision. All our studies about chemical effect. Chemical effect means we study about electricity passing through liquids. And then if the liquid is conducting, means if it is electrolyte, there will be a chemical change in it. A chemical change creates a chemical effect. Some sort of chemical reaction will take place. The charge carriers in this case are ions, which are of two types, cations and anions. What is an ion? An ion is an atma, intermediate entity, which has been created after an atom has either gained an electron or lost an electron. If an atom gains an electron, it's known as an anion. If an atom loses an electron, then it creates a cation. Okay? And what are the types? What are the examples of electrolytes? Acid, bases, and salt solutions. Salts don't conduct electricity. Salts in their aqueous form only will conduct electricity. Now our next target is to find that given a liquid in your hand, how will you understand whether it's an electrolyte or not? So we stop our discussion out here. Next class, we'll go ahead from here. Righto?